Dhanajan Yadu, I think we are good to go, right?
Yes. If we can, we are good to go. Let me know whether we should start now or wait for more participants. Should we start now?
I think we can start now, right, Yadu?
Yeah.
Okay. A warm good evening to all. Welcome to another session of Fab 16. Fab 16 is one of the most awaited annual events among the Fab community. Every year, the makers from the 2000 plus Fab labs spread across the 100 plus countries used to eagerly wait for the Fab conference and participate with passion. This year also, Fab 16 witnessed an amazing turnout and participation. But unfortunately, since we are still in the midst of the pandemic, there is a change in the format. Unlike the previous editions, this edition is conducted as a distributed event where local nodes conduct workshops and webinars for that region. Fab Lab Kerala is happy to host the events in India region. Thanks to all the other labs in India for contributing to the show as well. Speaking about the current session, the today's session, it's in fact the last session from the region, and I feel we have one of the most glamorous topics as rightly as a penultimate event of that. So that's regarding the 3D printed houses and digitalizing construction. Since 2016, Tvasta team has been redefining the construction field. Founded from the passion of the founders, Mr. Aditya, Vidyashankar, and Parivartan, in design and because of their passion in design and 3D printing, Tvasta has been a beacon of light in spreading awareness about the technology and also about the business potential of this technology. How 3D printing and this can be applied in the construction. And today we have Mr. Sriram from the leadership team of Tvasta to share their journey and insights. He has been with Tvasta for almost 5 years now, since 2016, and has a diverse experience from concrete printing to ceramic printing to metallic printing and all. And before joining Tvasta, he's been a research engineer in metallurgy, and that experience and in fact add value to the kind of work he does. He wears multiple caps as a product designer, as a manager, as a partnership guy. He's a man of different roles and responsibilities. So it's a privilege to welcome Mr. Sriram Raghunandan to the session. Mr. Sriram, please.
Yeah. So thanks, Dhanush, for introducing me. It's a pleasure to be here and present our works about Tvasta. So it's pretty exciting to see that you guys have invited us for this session. So I'm pretty excited to present our work and looking forward for a discussion. So without much delay, if I can start with the presentation, that would be great, right? I hope you guys are able to see my screen. Yes or no?
Yes, the screen is visible. Probably you can make it a full screen.
Yeah, sure. Just a minute. So I'll start my presentation with the making of the 3D printed house that has been the headlines in the country for the past few months. So this is the first 3D printed house that was made and installed inside IIT Madras. One big fact about the house was that it was made amidst the pandemic and then the storm in Chennai. Thanks to it, because without it, it wouldn't have been a much topic of interest. And going back to it, what you're going to see is the making of each stage of the 3D printed house. So this is the technology that we have developed. One interesting fact about it is that the entire technology stack is a made in India initiative. So we made the entire hardware, software, and then the materials. We researched and developed the materials, and then we also 3D printed the house. So we are proud to say that we are a made in India startup who have completely revolutionized the construction field using 3D printing. So what you're seeing is a 3D printer which is inside the factory. If you are in Chennai, please feel free to visit our factory. So, per day it prints around 2 tons of concrete. I just wanted to start out the presentation with the video. So, and the next stage, what you're seeing is the assembly of the prefabricated modules. So the step how it happens is we 3D print the modules in the factory. We take the modules to the site, and then we assemble it and we finish it and we kind of deliver it to the customer. So yeah, what you're seeing is India's first 3D printed house. So in few places, the 3D printed finish would have left intentionally because that is the raw and rustic finish that most of the people like. But I think going by majority, most of us like a very smooth finish in house. So that is why we made it as a combination of both. And one good fact about is that this was completed in a month. It took around 2 weeks for us to 3D print it and 2 weeks for us to assemble it. So we are coming up with more advancements to 3D print the entire house in less than 2 weeks. So what you're saying is like beautiful architectural elements that 3D printing can make use of. This has been installed specifically outside the IIT Madras gate. If you ever come to Chennai, please feel free to visit it. And these are some customizable chairs that we have done, like pretty much some brand logos, customizable chairs using 3D printing. So the idea is that we make use of the customization of 3D printing, and then we deliver the best product to the customer. And I also want to take a moment to mention that we have been mentioned by our Honorable Prime Minister's Man Ki Baat. So last edition of Man Ki Baat.
Sriram, I'm afraid the audio is not coming.
Oh, is it?
No.
Okay. All right. Yeah. So I think pretty much what our Honorable Prime Minister was saying was that by using 3D printing in construction, we can save a lot of time and a lot of efforts. So we can reduce the labor dependency completely on the process. So yeah, that was just about it. So this came out recently. I think just 2 to 3 weeks back. Our Honorable Prime Minister mentioned about the construction 3D printing in Man Ki Baat. And apart from that, we also had the privilege of meeting Honorable Vice President of India, Shri Venkaiah Naidu sir. So he mentioned that this technology can be specifically used in disaster management and affordable housing. And apart from that, this entire 3D printed house was inaugurated by our Finance Minister, Srimati Nirmala Sitharaman. So I just want to take a moment to share, the information. So I'll quickly go into the presentation. Yeah. I hope you guys are able to see my screen, full screen. Yeah. So Tvasta. So what Tvasta means that Tvasta is a Sanskrit word which means creating something out of nothing. So when we started out in 2016, Tvasta started out from the idea that we were a small 3D printing club in IIT Madras. So the idea to do something extraordinary using 3D printing inspired us and motivated us to take it forward. We started working on this construction 3D printing in 2017, and we had Professor sir, who is currently the HOD of IIT Madras Civil Department, who mentored us and guided us with respect to developing this entire technology. Initially, the reason why we wanted to get into the machine building or the technology side of the thing is that in India, if you look at it, we mostly import the technology. So the technology development is generally not a trend. So that is where we wanted to make a difference. So what Tvasta did was we built the entire machine, and we also built the software to control the machine, which will give a very good control over the printed parts. And then we also researched and developed a 3D printable mix. One good thing about concrete is that concrete is a non-Newtonian fluid. It means that it becomes liquid when the pressure is applied, and it becomes solid when the pressure is removed. So we entirely engineered the material 3D printable mix using this principle. So we were fortunate enough to have the guidance of IIT Madras during our prime years to work on this technology. So that's about it. And the nature of company, as you know, we develop technologies. It is a deep technology company which develops technology and which works on applications associated with the technologies. So yeah, so we develop the end-to-end platform of it, be it hardware, software, materials, and also the services. We offer everything end-to-end. And I'm definitely sure as youngsters, you must be aware of 3D printing. 3D printing has been around for around 20 to 25 years. But mostly what people talk is that 3D printing for prototypes or the plastic 3D printing. But 3D printing is much, much beyond that. At this point of time, there are 15 to 16 technologies in 3D printing. And it can be applied across different materials. So I think plastics is being one of them. Ceramics, composites, concrete, biomaterials, anything can be 3D printed, and that is what is a very interesting thing. It keeps interesting. It keeps inspiring us to explore different avenues of the 3D printing. Any material can be 3D printed, and that is where our search is towards. Yeah. So sticking relevant to the topic, there are 4 critical aspects in the concrete 3D printing. The first thing is the machine. So broadly, there are 2 types of machines. So one is a gantry and second is robotic arm. Gantry has 3 axes X, Y, Z, and robotic arm has 6 or 7 axes. So what Tvasta initially, we started building gantry systems. We started out with a technology called offsite 3D printer, which means that the machine will be placed in the factory, and as we showed, right, the video, the machine will be placed in the factory, the models will be printed, transported to the site, and then assembled. We are also working on a concept called on-site 3D printing, wherein the machine itself, in a modular way, can be transported to the site, and the entire printing process can be carried out. Apart from that, we are also working on robotic arm printing, wherein it gives different options of customizable designs or overhangs. So that is about the machine. And material, as I told, the concrete, I think we have engineered it in such a way that it is 3D printable. One big challenge is that it has to bear its own self weight. 3D printing is nothing but a layer by layer deposition of the entire design. So when each layer deposits, the concrete has to bear its own weight. So that is the challenge. We have developed the material in such a way that it bears its own weight. And software, as I told, to control the end properties and to also give a user-friendly interface when you're interacting with the machine. So the software that we have currently developed estimates or it optimizes the design. Like, for instance, it tells that for a particular design, how much material is needed, what is the printing strategy you have, and what is the layer height, what is the size. It gives you every other information. And one interesting thing is that we are also trying to integrate direct BIM models to our software. So in such a way that the construction files can be directly uploaded to our software, and it can start printing. The last thing is the printing strategy, which we have already mastered over a period of 4 years. So some applications demand a higher strength, and some applications simply do not require that strength. So we at Tvasta, what we do is we look at the end application, and then we design the printing strategy. It can be done with steel reinforcements. It can be done without. We customize the mix design accordingly, and then we customize the printing strategies according to each and every applications. So the idea why we started out, or why we started working on such a path-breaking technology, is to automate the construction process. So as you all know, India being a kind of a growing country, we face a lot of challenges with respect to labor, or to be very precise, skilled labor. The lot of projects have been delayed, and a lot of timelines have been postponed due to the lack of skilled labor. So one one important thing, if you look at, is automating the entire process, which are monotonous in nature. The idea is to not cut the labor, but to automate the process and make people skilled or trained to operate the rest of the process. So if you look at it, we work on different applications, housing being one of our primary applications. So we also work on both premium and affordable housing. Tvasta is closely working with the Ministry of Housing and Urban Affairs to come up with the affordable housing in housing for all scheme in 2022. So as a part of that, we are trying to see the slums and other remote areas if we can actually bring in this concept and then start implementing it. And one good thing is that instead of the straight structures, we can bring in curved walls, curved elements, and then we can add the customization to the straight structures. So, and apart from that, the small structures used anywhere. It can be toilets, cabins. I think we recently also built COVID isolation wards for the frontline workers in order to honor them. So, yeah, I think the applications may be anything. And we also deal with mission separate architectural elements. So it can be the outdoor furnitures, which can be customizable, and it can be facades, it can be any brand logos, and customizable walls. So we work on different applications. So as you see, they are our founders. They all the three are from IIT Madras. So what you are seeing here is the India's first 3D printed structure, which was built in 2018. Once we started working on this technology, we completed the machine in early 2018, and the structure was quickly built to demonstrate the capabilities of the construction 3D printing on the concrete 3D printing. So this was inaugurated by the Minister of Housing and Urban Affairs. So they were there in IIT Madras 3 years back. We had a conference on this to say the potential of the concrete 3D printing and how it can be helpful in constructing houses for the nation. So what you're seeing is the image of India's first 3D printed house, and I'll just walk you through the house. So these are the interiors of the house. So what we do is that the entire walls and the vertical elements of the cushion. So the walls here is a load bearing walls, and the entire walls were 3D printed. The foundation in this case was done using conventional, because the foundation and the 3D printing walls can be done parallelly. The roof, what we can do is that we can 3D print the formwork and then we can pour the concrete. So in that way, I think with a mix of technologies, the idea is to completely reduce the lead time. So we are striving hard to finish the house less than 2 weeks using our on-site 3D printing technology. So yeah, and this is a doffing unit, which means that it's a COVID isolation ward. So what we have done is that it is a 120 square feet structure, wherein the frontline workers such as doctors or nurses, they can dispose their PPE kits, and they can use this room to change, or they can use the room to refresh. So this has been done across 3 hospitals in Tamil Nadu. This was recently inaugurated by the Tamil Nadu Health Minister, Mr. M. Subramanian. Yeah, so the process flow for concrete, the first step is the design. Once you have a design of how the building will look like, you will have to input the design to the software. So our software especially uses STL file as input, but now we are also developing, as I told, we are also developing to input the BIM models directly into the software. So what it does essentially is that it slices the file to G codes, and then it feeds to the machine. So as you all know, like a CNC machine, a 3D printer also understands G codes better. So it slices the file and sends the G code, communicates the G codes to the machines. And meanwhile, as you all know, we make the concrete paste. So the concrete paste, I think what it consists of cement, sand, and then some other additives which make it 3D printed. And once these both are given to the machine, it starts printing layer by layer, and then your final physical model is obtained. So after this, in offsite, what we do is that we transport the modules to the site, we assemble it, we plaster, finish, and then the entire work is done. But in onsite, what we do is that it starts printing all together one, and then we just plaster it and project is done. So what you're seeing is our factory, which is in Chennai. So it's a quite huge machine. So the machine is in the dimensions of around 3 meters across, 4.5 meters across, 1.5 meters. We are even building a bigger machine, in the range of 8 meters across, 10 meters across, 5 meters. So both on-site and off-site. So we do have quite interesting projects lined up using our machines. Yeah, this is a quick render of the 3D printed house. So this 3D printed house was done using offsite concrete printed technology, and it was done in collaboration with Habitat for Humanity and IIT Madras. So, I would also like this, like to take this opportunity to walk you through one of our customized, niche elements that we have developed. So these kinds of elements you can never see it anywhere. We have put in a lot of efforts and these kind of patterns, which is only possible using 3D printing. Even it cannot be replicated using it. So these are facades. These can be kept in the front of the buildings and can do the wind load. Yeah. So if you look at what 3D printing is solving in a bigger picture, 3D printing, the world needs a solution which is affordable, sustainable, and speedy. Affordable when you mean definitely cost effective, and sustainable. There is a lot of carbon footprint which is being used, and as a part of that, it directly contributes to the global warming effects. And in order to counter that, we need to move towards a green, sustainable solution. So that is something that a lot of activists or enthusiasts have been enforcing. We need to move towards a green and sustainable solution. So and speedy as such, time is money, and we have all heard of many stories wherein their dream house of it takes 8 to 10 months and it has taken years to complete. So with this technology, mainly aims at being affordable, sustainable, and then speedy. So we are already there in the speedy. The project which has been done in 6 months has been done less than a month. And sustainable, yes, we are working with a lot of elements that will reduce the carbon footprint. And affordable, we are working towards it. In next 2 to 3 years, we'll be as competitive as the conventional or any other technologies. Yeah, and this is just to tell that we have a great housing demand, and this is like what we can cater to is not even less than 10%. So only if a conglomerate of technologies come together, we'll be able to capture the demand, or demand versus supply gap will be very less. Yeah, I mean, in rural India, I think there is a desperate need for housing, because they already that there is a little bit of different infrastructure, and then due to which the mode of living or the quality of living has declined. So providing houses to them will contribute to a lot of other factors, and that will also improve the condition of the nation. So I think. So this is a comparison of the construction industry with other sectors like manufacturing, agriculture, transport. If you look at it, the productivity of construction has been dipping. It has been going down and down in the past 50 to 60 years, whereas the other industries, it has been showing a good upward progress. So one reason what if we can map is that lack of adoption of automation. So if construction industry can adopt automation, uh, you know the monotonous works which has been doing and which doesn't require labor really, if that can be automated, that will really increase the productivity. Yeah. So in India, as you know, we have the housing shortage, massive housing shortage. So in order to do that, I think 3D printing as a solution will increase the productivity, and then it will start working on the housing demands, and then it reduces the wastage. So as you all know, it exactly deposits the material that is required, and it also has hollow walls and with infill pattern, which will bring in a lot of other benefits like better acoustic properties, insulation properties. So in that way, it kind of adds a lot of value, and 3D printing obviously increases the productivity. Uh, yeah, so the cost finally, as you all know, if you reduce the labor and if you reduce the material wastage, it is going to bring about the cost savings. Yeah. So if you look at the advantages of this technology in a nutshell, the first thing I would say is the lead time. It completely automates the areas which are the walls, which constitute most of the area. So easily it can automate up to 80%. So you're talking literally about days, and the foundation can be done parallelly once, while doing the walls. The roof can also be done easily. So you're literally reducing the lead time of the entire process. The second thing is that you're reducing the wastage, which will also bring about the point of cost savings. So due to reduce labor and due to reduce the wastage, we are enabling the cost savings. The third thing is the design flexibility, I would say. As you all know, 3D printing can bring in the customization. So any kind of structures can be, developed using 3D printing. You don't have the constraint. You don't have to think of it in the matchbox or the straight squares or rectangles. You can go crazy in design and you can execute any kinds of buildings. And the second thing is that, since it has hollow walls, you can integrate the mechanical, electrical, and plumbing wirings while printing. So which will kind of increase the productivity. So in that way, once the building is done, you can move towards something like a plug and play houses. You can directly start living there once it has been done. And yeah, I think these are the main reasons why you should go for 3D printing. Yeah, this is a quick comparison on the traditional versus the 3D printing. One thing is that our next goal or the future, what we would say is that the on-site 3D printer, wherein you can just take the printers and modules, assemble for a day or two, and then you can directly start printing any bigger type of structures. So I think you would have seen tower cranes anywhere. So probably our vision is that everywhere there is a on-site printer and which starts doing buildings in every part of the city or every nook and corner of the country. So that is where we want the 3D printing to be. Yeah, so Tvasta has been putting a lot of efforts with respect to building this entire ecosystem. So if you look at the technology, I think we have done the materials research with IIT Madras, and then we are also working with a lot of approving bodies like the government institutes to kind of work on the approvals or the regulatory approvals for the entire system. And we have developed the in-house capabilities of the developing the machine, material, and software. So with the technology front, we have spent 4 years of time in mastering the entire 3D printing technology. We have almost around 1,000 test runs, as it says, and we do hold some unique patents with respect to a few parts of the technology. And if you look at partnerships, so we are tying up with few cement manufacturing companies to come up with something like dry mix packages, which will be delivered in site and which will which when mixed with the wet mix, it starts with the 3D printing mix is prepared. And we are also closely working with a lot of architects and green consultants, and to making the house also smart and energy efficient. So I think Tvasta has kind of got end to end of this ecosystem into control, and we have been working with every influential bodies in this entire technology. Yeah. So if you look at it, the vision we have is that currently in this financial year, like we are building around 1 lakh square feet. So we are picking up different applications, like one from petroleum industry, one in the real estate, and one for defense. So we are picking up some different use cases, and we are trying to say that 3D printing is a value addition. And once it is there, I think we start working with partners, and we also establish centers, micro factories where the 3D printers can be installed and the projects can keep going. So yeah. Our next project is something that we are planning, multi-story structures. It will be a G+1 structure, which we will be doing with an on-site building. Yeah, as you know, and as much as it has advantages, we'll have to be honest that it has some challenges which needs to be worked on. So the initial cost of this technology is high because it has some challenges with respect to supply chain and a few other constraints. So if that can be worked out, I think, as I told you, in the matter of 2 to 3 years, it can be as competitive as the conventional technology. And awareness is something, again, a big point. It takes people a few. It takes a lot of time for people to understand what is it that we are doing, what is it that we are trying to automate, and there's also fear that it might even take away the jobs of laborers. So it certainly is not going to. So I think the awareness, the right kind of awareness that needs to be there is also something, a factor or the challenge. But I think that rests completely in the hands of the ecosystem. How we put the technology to them, and yeah. So expertise, like I would say, probably people should be skilled in operating. So Tvasta do has a lot of plans in setting up some training, courses, or we will definitely offer extensive training once the machine is there. So we do have a lot of plans with respect to training people on how to handle the machine. Yeah, as you know, I think we have been incubated by the Ministry of Housing and Urban Affairs, a technology accelerator called ASHA, which focuses on global housing technology challenge. And as you all know, we are an IT Madras alumni-based startup, and we also have been closely working with IIM Ahmedabad, CSA, CRC. Yeah, so. Yeah, and I think the most important part of the slide is the people. I think without a team which has a very high cross-functional knowledge, as in we have experts in mechanical design, we have experts in software, electronics, materials, structural engineering. So we all come together, sit on a table, and then make this entire solution possible. So I think it is the power of people that has kind of made this solution viable, I would say. So we still we have not stopped, and we still are researching on a lot of areas where we can push the technology forward. So we are working on a lot of exciting things, I would say. So I think we have a team of around close to 20 to 25 people, mostly mechanical engineers, because they design the entire technology or the machine and the mechanisms. And I think that has been the best part if you look at our technology. So it will be as competitive as the foreign technologies that you will see. And I think it's a high time that we should start adopting the made in India technologies, and we should be proud of our own startups. So I think, yeah, and I think that's about it. I'll be happy to take up any kind of questions the next couple of minutes.
Yeah, I think already in the chat. So which is like, are the 3D printed houses resilient to
Hello.
Yeah, am I?
I didn't hear you. Sorry, there was an issue.
Okay, okay.
Can you
So
repeat?
is it audible now?
Yeah.
Mm. So the question was like, are the 3D printed houses resilient to earthquake cities?
Yes. So if you look at it, we have kind of made it suitable to zone 3, the lowest earthquake resistant zone. But we are trying to get approvals. We are working with government organizations to get approvals that it can be used in zone 1, high earthquake resistance zones. So we are working towards it. But currently, it is earthquake resistant.
Okay. So someone asked like their hand, and
I I I yeah. Sorry, I lost you.
like if they wanted.
Am I the only one who's not getting it, or is there an issue there? Hello, hello.
Yeah, I can hear. Nitin, couldn't hear you.
Hello, Moto.
Hello, am I audible now?
Yeah. Better. Yeah.
Okay. Yeah. So someone was asking, they can they can shoot questions. Yeah, of course you can shoot questions either in the chat. Otherwise, you can raise the hand.
Yeah, I look at the questions. So, what is the cost of machine or rent for building villa type buildings? I think the cost of the machine we will soon probably be revealing it once we are not currently taking up any commercial orders, as in we are executing some pilot projects. We are executing projects to projects. So probably if you look at it, yeah, if at all we have a design in hand, we'll be able to give you an estimate of what the budget for the entire project will cost. But the machines, it will take a while for us to give an estimate. Yeah. So what maximum grade in MPA you were able to achieve? So actually, it's a very good question. So we were able to achieve something in the range of 50 to 60 MPA in our first thing, but I don't think that is necessary for a house. So we easily can achieve the strength close to 20 to 25 MPA. What I'm trying to say is we can achieve even higher strengths than that. Is it necessary to have reinforcement structures in the 3D printed structure, or just concrete would withstand the usual natural stresses and elements? Yeah, thanks, Vatsal, for a good question. So depends on the application. So if you are going for infrastructural, application wherein you require a very high strength, what we do is we put in the factor of safety, and we do go for steel reinforcements to make sure that it withstands the wind, it withstands any other properties. But for a very normal building or something of those sorts, I think our walls are designed in such a way that you can probably the walls bears the weight, so it can be of a very normal. The concrete alone is enough. What about the maximum size of aggregated? Yeah. So we currently use 2 mm motors in our mix. That gives a very, very good strength, but we are also capable of doing it up to 8 to 10 mm. So, how long of an overhang can print, or do you use support structures? So with yeah, I mean, we can use a little bit of sand backing, or we can use wooden supports and then go as much as possible. So I don't think there is any restriction of that. And with robotic arm also coming to the picture, I think it is definitely possible to print overhangs of, there is not much of a restriction. It can be done. But yeah, I think with gantry, I think we need support structures to do that.
Hello, am I audible?
If someone is
Hello.
passionate,
Yeah, you are audible. You can shoot your question.
Yes, sir. So I have question regarding the incorporation of reinforcement. How do you incorporate the reinforcement in your printable concrete to
Yeah.
achieve some tensile stress? Like at some places, if you need to put a printed beam, then how would you achieve that?
Yeah. So what we do is that we go for both the types of reinforcements. So horizontal steel reinforcements like chicken mesh or something between the layers, between every layers, it is possible to do that. So that is also one thing. And since our walls are hollow, if you look at the photos or if you look at the slides that I showed, since the walls are hollow, what we do is that we finish the wall and then we integrate the steel rebars into that, or you can have the steel rebars and then print around it as well. So I think there are two ways of doing it.
So my question was like, how do you put the reinforcement? It is by manual placement or by
Yeah.
automation
So
only?
currently it is done by manual, but we do have plans of doing automated reinforcements. Yeah, we do have plans. Thanks for asking. Yeah.
Okay.
And yeah, I have a question from Ramit Shrestha. If someone is passionate to learn about construction 3D printing and make a career in it, where should he or she start from? And should it be from software, hardware, or material science? If you could please guide. Yeah, I mean, thanks for this question. That depends on where your area of interest is in. For instance, if you have a interest in materials, I think you should you can probably have a career wherein you design the entire 3D printable mix. You come up with various mixes, and then you kind of according to the applications, you evaluate the mix with the different properties. And the most important or the challenging part is that it has to be extrudable, and it also has to kind of be buildable. When I say buildable, it has to take the load. So I think if you look at materials, that is the challenge. You'll have to come up with that kind of a material mix design. And if you are a mechanical engineer, I think you have a pretty good scope in design and manufacturing of the entire. So you can design the machine, of any mechanism. We are pretty much open for people who are looking to aspire careers in mechanical engineering. Please follow our social media and LinkedIn for more job updates. So if you want to work on hardware, I think that designing the entire machines and then manufacturing it is the right scope. And if you are from software background, I think UI or UX design, and then you have a very good hands-on in C# or any other programming languages, I think you are good to work with the software. So I'm saying, and if you are from a civil background, I would say that you have a lot of scope here. So right from the structural, the design validation. So you can be a part of the process anywhere. So there are various scopes for the entire thing, and it is up to you and your area of interest to choose. So depends on what your area of interest is. If you can, I'll be more than happy to help you if you have any other questions, probably off this entire seminar. So Tvasta thought of doing hybrid buildings like 3D walls and precast slabs to have save time. Yeah, Alan Thomas, I think that is thoughtful question. So we are looking at the concept of hybrid buildings, and I would say that we have already, we are looking at it that way. We are not just hung up on 3D printing. Just because to use 3D printing, we are not using it. So 3D printing makes the best use only when during the vertical structures. For horizontal structures like slabs, it is better that it is cast. Rather than 3D printing a horizontal element, it makes sense to 3D print a vertical element. So I appreciate your question. The answer is yes. I think that is the way to go. Whatever is the best done using the technology, you'll have to go for it, and you can't force fit the technology to do everything. So to save time, I think we'll have to use a combination of technologies. Is 3D STR designs currently in compliance with building codes? Are you asking STL designs? I'm assuming you're asking STL designs. So I don't think that has anything to do with the compliance codes. So STL designs are designs again, like whatever the 2D drawings you do, right? So what we are doing is we are importing it as a 3D model, and then we are doing it. So I would say, I mean, that doesn't have anything to do with the codes. But if you are talking about, the structures G+1, G+2, G+3, I think that has, that has a dependency with the building codes. So currently, there is a limitation that we can do only up to G+2. So Tvasta is trying to next do a project of G+1 to start and evaluate the entire technology, and we will definitely get the compliance and then go up or start building multi-story structures. How do you prevent the structure from sagging when printing with a viscous material? It will take time to solidify. So what we use is that we use a special type of material. That's a proprietary material. So it hardens up the entire layer before the next layer starts. So that way, I think it hardens quickly. It solidifies quickly. Why do you think ceramic printing is not as prevalent as polymer 3D printing? Is it access to tech or some other reason? Okay, so that's a very interesting question. So ceramic 3D printing, if you look at the applications, I would say refractories, abrasives, these are the applications, and there it requires precision. So I would say precision is the reason why ceramic printing has not been that much mainstream. But if you look at concrete, if you are comparing, okay, you want to compare it with polymer. So polymer, it has been proven that the precision is possible. Laser precision, or even if you talk about FDM or selective laser sintering or VAT polymerization. So you can go down. You can. The precision is it's very accurate. Whereas for ceramic 3D printing, that is not the case. Like it's still we are still exploring the materials that can be 3D printed using ceramics, as in silicon carbide, aluminum oxide. So it's still I would say in a very nascent stages. But I think there is a technology called binder jetting, which probably will bring in the precision or that for ceramic, and hopefully, I think Tvasta is also working towards a technology like that. Let's see, what the future holds for us. The pilot project of Tvasta, the MEP first fix was done along with the printing or done post cast with like normal buildings? Yeah, it's a good question. So in one of our projects, the COVID isolation wards, so we tried out MEPs during printing. So I think that was an interesting experiment, and that was successful. So what we did that we gave provisions to the building while printing, and then we integrated the plumbing lines and electrical lines. So it was successful. I would say we had tried it. Yeah, and if you guys have any questions, feel free to connect with me on LinkedIn. Sriram Ranganathan is my ID. So please feel free. Whenever I see, I'll definitely respond. If you need any guidance with respect to your careers or anything, please feel free. I will definitely make sure that I'm free.
Yeah, Sriram, I have a question. Can you tell how tough or how easy is the on-site 3D printing compared to the prefabricated? So you have to install the machine, you need support structure, and also how tough it is.
If I understand it right, you're asking how difficult it is to install a concrete machine.
Yeah, the on-site 3D printing.
Oh, okay. On-site 3D printing, I would say it is not that difficult. As in, see, the idea is that it is kind of, it comes in modules. Like, if it's like 20 meters height, we divide it into, 5 meters of each section. And what we do is we assemble. It takes 2 days or 3 days to assemble. And once it is assembled, you imagine a tower crane, right? Like, have it like a tower crane, and we just assemble it. We can take it in a a parcel, like we can take it in a vehicle, and then a truck or anything. We can, in the site we'll have to assemble it, and once we assemble, it takes assembly time, I would say. So probably we are estimating when we start out, it will take a week, but eventually it should take less than 2 days to assemble. And once we assemble, and once we set up the entire thing, I believe it is pretty much straightforward. So one more thing is that we'll have to integrate the pumping system to the entire machine. but I think that is also automated nowadays. Like, you have mixer and pumping in a single unit, integrated mixer and pumping unit. So you just have to kind of mix, and it will automatically pump it to the 3D printer, and it will start printing. So yeah, I don't see it as complicated. I would say it's definitely doable.
Okay, so any further questions? Kindly drop it in the chat, or if you want to come in, you can raise your hand and you can ask directly.
Alan, please proceed.
Thank you. I just have a great technology, by the way. I just have a small doubt. I saw a front arch which is kind of looking upward with a gradient. Was that done as a conventional slab or was it 3D printed?
No, that was the formwork. Probably it was 3D printed, but it was just cast. So cast in situ. Yeah.
Okay, and as far as the wall height is concerned, I think you are going ahead with these 20 cm thick walls which has cavity inside. So
150 mm thick, 150 to 200 mm thickness, wall thickness.
Okay, what is the height possible without having the necessity of a column or another reinforcement? Like with the 3D printing alone, how high it can sustain?
So if you can look at it, the wall. So yeah, I'll tell you the dimensions. So currently the wall thickness, if you look at it, it is around 150 to 200 mm, and the length and this thing, I would say we can go up to 2 meters in length, and then height you can go up to 1.1 or 1.2 meters. So a single module of a 3D printed wall will be like 2 meters in length, 1.2 meters in height, and 200 mm thick, or 150 to 200 mm. It can be customizable. So that is.
Oh, okay, and given that answer, now suppose the wall height is let's say take about 2.5 meters, which is some kind of a standard here, 2.5 to 3 meters. How do you integrate between two 3D walls, one on the other? What is the integration mechanism?
So we kind of join it using motors. So that is actually, if you look at the video I showed, right? We take it to the site. There will be several modules. For instance, the house has around 45 modules. So what we did was we paste each modules, we grouted it, we paste it with the motor, and then that itself is that joint is sufficient.
Okay, now given the, I believe with the 3D walls, the weight of the structure would have considerably come down because there is a lot of hollow structures and the superstructure weight would have come down. So is it helping the foundation to be lighter or is it the same?
No, as in, I would say there is still a long way to go, but it is somewhere we are there in the range of conventional. I think a little bit lighter maybe, but I think we can completely go even lighter. So since it was the first project, we kind of over designed. Sorry, hello.
Yes, proceed.
Yeah, sorry. So yeah, I would say that we can still go down. The foundation what we are currently using is conventional. Like the foundation is done using conventional. As I told you, horizontal things are done using conventional. So we still haven't found a reason why we should 3D print a foundation, except the fact that it saves time. But during printing, we can parallelly do the foundation in a manual way. So I would say, yeah, probably we can still go down a little bit on weight, but currently since we have over designed it, I would say.
Okay.
Sorry.
Yeah. Can I ask you one more question?
Yeah, please.
Yeah. You said you're using the conventional slab systems. Now, are those conservation slabs, is it a two-way design slab, or are you placing it only as a one-way rip slab to reduce the load on the walls? Is it a two-way slab or a one-way slab?
It is actually a two-way slab. Yeah.
So given that the case, if you want to say, let's say demolish a few walls in the later stage, you want to make a room a little bigger. So in those case of scenarios, you advise scaffolding to be put in place and the conventional wall can take its place, or a 3D printing wall itself is necessary as the new wall. How do you think it will go?
See, if at all there needs to be a renovation made, I think this using 3D printing, if we have planned it, I think the modules will be there and stuff. But I think during renovation, I guess we can definitely replace it. Yeah. So that is a very good question. I think we also have to, since it's a new technology, we have to also figure out our way into use cases like this. Only once we are able to do it, I think we'll also be able to tell it. So as far as now, we haven't honestly had that idea of going towards it, but I'm sure it can do. Yeah.
Perfect. And while you're finishing the walls, I believe the walls have a textured finish, which is actually good. But as you said, taste differs. So the finishing of the wall in the smooth surface, is it done during the casting itself, or you're applying a finishing mortar at a later stage to make it?
Okay. So I'll tell you what we are doing to encounter that. So for instance, during the printing itself, right? The nozzle is like this, and then the concrete comes out of it. We are also planning to have integrated trowel there, and then which will slightly smoothen the entire layer. So that is something that we are working on. But I would say that currently what we are doing is the textured finish comes out of the entire module, and we plaster it once it is out, and then we plaster it and then we finish it as of now. But the plan is to automate that as well to get a very good finish during the printing itself. So we are working on it.
Okay, and perfect. The concrete mix which you are advising for your machines and the technology, has it been patented to Tvasta, or is it some kind of proprietary of another company?
It is no, it is definitely developed by Tvasta, but I think it is fairly straightforward. But Tvasta uses a few other ingredients to make the process even more efficient, or to say we just add something on top of it. But I think the recipe fairly remains straightforward. So, but what we use is something that we have developed. We have developed and we have patented it.
Perfect. I think I've asked too many questions. Is it possible to have an offline meeting with the company or something? By the way, I'm a low-cost housing expert who has been working in Oman before. So low-cost housing is my area. We also work with companies from South Africa. So definitely this sounds very interesting. So does your company entertain people at this moment to come and see the buildings?
Not at this moment, because we are in pandemic, and probably at your own cost, if you can drop it by IIT Madras, it would be great. But if you want to discuss anything with us, currently we are holding it on, because as you know, we are doing a lot of pilot projects, and probably once that is done, we will go on full commercial mode. But anyways, you are most welcome to contact us via call. The number will be given on the website. So you can give a call, and you can have a discussion with one of our representatives, and we can definitely help you with whatever you want. Yeah.
Perfectly, all right. Thank you so much.
Please feel free to reach out.
Okay.
Thank you so much, Alan. So we have one more question. Can on-site printing be done in those riverbank soil or beachside soil? I think.
Sorry.
So we have one question in the chat.
Oh, okay. Yeah, I saw that. So I think everywhere you need the soil testing reports to be there. It is don't think it of something extraordinary. It is like wherever you construct normal houses, I think that is where you can also construct 3D printed houses. It's not something extraordinary. But yeah, I mean, the soil has to support. So the soil test reports, I'm sure if you guys have anybody of your structural, I believe you understand that. So I'm sure it has to, whatever the normal buildings take, the soil has to kind of be there. But however, we are also trying, this is on a very different note, we are also trying to 3D print using organic materials soil, and then some earth-based mixes and stuff. So you can use that as a mix, but with loose sand or loose soil, I don't think if normal building is not possible there, I think it is not advisable to go for a 3D printing there as well. Hello. Am I audible?
Yeah. I think we have like a lot of questions answered, and thank you so much for being here, Sriram, with us like for this wonderful informative session. Since like even for myself, like it clarified many doubts, and like 3D printing was always like a dream sort of thing. Like, and our generation is lucky enough to see the ground the ground impact of the like evolution of 3D printing as well. So from FDM to SLS to MJF to now we are building houses. Like it's always an amazing like an amazement for like a human being. Yeah. So I thank you so much for taking time to for this informative session and clarifying our doubts. And also, I would like to thank all and everyone who has gathered here and nearby Fab Labs. We do have people from Bhutan, Nepal, and nearby in all Fab Labs around from all the region as well. So I would like to thank all the Fab Labs, makerspaces, and all the enthusiasts who have joined this program. Thank you, Sriram. Thank you very much.
Thanks a lot. Thanks a lot for this opportunity. I am truly, it feels great to, have a discussion here. I'm sure, there are a lot of questions still there. So I would say, feel free to reach out. I think the best thing we can do is to educate or help each other in understanding what we do. So anytime, so feel free. Thanks a lot for this opportunity once again, and I really look forward to interact with one of you guys definitely in future.
Sure.
Thanks a lot. Yeah.